Today we're going to be looking at predicting the products of chemical reactions when we have just the reactants. Okay, so in order to do this, I want you to go back and watch the different types of reaction type videos, just to kind of refresh on, what those reactions look like, when you have the reactants and products. And then, study the reactants. What kind of reactants do you have? How many do you have? And so forth. And then look and see if are the elements, are they compounds, and then within those elements and compounds, are they metal oxides or non-metal oxides, or are they acids or metal carbonates and so forth, right? So take a look at those, and then take a look if they're compounds and they're switching places and so forth. Okay, so just take a look through there and then start this again. Okay, so I have on the first page all of the reactions, some important information from all of the different reaction types that we've been studying in this unit. So the first one I think we looked at was single displacement. We looked at how a single metal was coming in and displacing another metal, or it could have been a single non-metal, one of these four, displacing each other. So we figured out from running a lab and so forth, that there is a list that comes about where some metals are more reactive than other metals. So we have this activity series list. So if you're at the top, you're the most reactive. You'll go in and you'll displace the other metals. And then if you have a non-metal, you will displace a non-metal. So if you see here, like a fluorine will take out a fluorine. Like a fluorine can take out the chlorine, bromine, or iodine, okay? All right, so, and then there were some specific things like you have to watch out for, okay, so when it's being combined, a single metal is being combined with water, these metals in this blue box here will be able to take out the hydrogen off the water. If you were in the red box, these metals will be able to displace the hydrogen from an acid. Okay, but then if you're outside of the box here, you won't be able to take out the hydrogen, or you won't be, like if you were magnesium down onwards, you won't be able to displace the hydrogen from a water. Okay, so so just go back and review those if you aren't comfortable with them. The next thing we looked at then were the combustion reactions. We looked at incomplete and complete, and a little bit of the elemental combustion. So I want you to focus just on the complete combustion today when you're trying to identify the reaction and the products and so forth. Okay, so just assume that it's a complete combustion that we're analyzing. Okay, and then from there, so just to look at that quickly, so you have some hydrocarbon, a carbon-hydrogen combination here, placed within oxygen, and we're going to assume there's an excess amount of oxygen, unlimited amount of oxygen, so we always get the carbon dioxide and water coming out. All right, from there, we looked at double displacement, I believe, next. So you're going to use these tables here, these boxes, I guess, to let's move this down. I think I'll leave it. In order to figure out, so with double displacement, you always had a compound and a compound. Like if you take a look here, compound, and they used to swap places, right? So from there, that lesson was we were trying to figure out, like they would both start aqueous. The two reactants would be aqueous, but then one of the products, because we were looking at precipitation reactions, one of the products could come out as a solid, okay, or low solubility. So we were trying to figure that out by using these boxes. So same thing, go back and look at this lesson if you are not too comfortable with it, okay? All right, so again, but you can identify that because you have a compound and a compound, right? The only other one where it's compound is the combustion, but you would have a hydrocarbon and oxygen, so that's how you can identify those, okay? All right, the rest though, like the single displacement, you have one metal coming in with a compound. See, it's different from synthesis and decomposition, okay? All right, so then from there, we did synthesis and decomposition reactions. So with the synthesis reactions, you're gonna have like an element and an element coming together, and then they just combine together. or you're going to have a metal oxide in water or a non-metal oxide in water. And these are the products that you'll form. So metal oxide and water, you're going to get a base, okay? And then non-metal oxide and water, you're going to get an acid. So this is the one I was trying to help you guys remember by think if you're putting carbon dioxide, that's a non-metal oxide, into the air where there's water, you're going to help promote acid rain, right? So that's how an acid's going to form here, okay? So make sure be comfortable with those. And then decomposition. So you start with one, but you break apart into pieces. So not necessarily always two. You could have three, four, etc. So here are the different decomposition reactions. So again, remember, I'll provide you this table. I'll provide you this single displacement, the double displacement, right? So a lot of these things here will be provided. I won't give you this though, okay? So make sure you understand the difference, okay? But anyway, this sheet's here as a guide to help you along with the questions today because all these reactions will be mixed in the practice, okay? All right, so here the decomposition, you start off with one and then it breaks apart depending on what type of reactant you have, metallic carbonate, metallic bicarbonate or hydrogen carbonate, metallic hydroxide, metallic chlorates. Okay, I'll probably add more in the future. And then just oxyacids, so acids with the hydrogen, oxygen plus another element. What do those break into? So use this as a guide to figure out what kind of products you should form, okay? So all of this is really important. You have to make sure you get the right formula, the right product, and because I want you to also balance and write the state symbols, okay? So state symbols, there was a video on that. I want you to review that as well if you're not feeling comfortable. So it's kind of like this is like our getting towards the end of the unit. So I want you to be able to put everything forward here now. Okay, so we're going to try some examples. And then if you want to stop the video and try to do it yourself and then start the video to double check your work, you can do that as well. Okay, so here are the examples that we're going to go through. And then I highly recommend going through lots of practice questions today. Okay, so I want you to do four things here. I want you to identify the reaction type first, and that's really important. Like figure out what's happening and what's going to happen in order to figure out what will the outcome be when this reaction goes through. Okay, actually, if the reaction goes through, that's something that I should say. All right, so then from there, predict. Okay, so once you figure out the reaction type, you should be able to predict the products. Make sure you write the correct chemical formula. Then from there, balance the equations and write the state symbols. So yeah, so basically if the tough part here is just being able to identify the reaction type and then find the products, if that's the tough part for you, once you kind of watch that part of the video and you're done, you can stop because really if you know how to balance and write state symbols, you don't have to watch the rest of the video. Okay, so let's start with the reaction types. So again, what are you going to have, say, on a test and so forth? I will give you the different names of the different reactions. Okay, so synthesis, decomposition, single displacement, double displacement, and combustion, right? But I won't give you like this visual here. So you should be able to, I don't know, once you get your test, maybe draw a little quick sketch of, oh yeah, synthesis when, like a couple things come together and there's one product. Decomposition is the opposite. You start with one reactant, but then you get two or multiple products. Okay, single displacement, that's when a metal comes in and displaces a metal, or it could be a non-metal and a non-metal displacing a non-metal, okay? But again, you need the activity series, pay attention to that. Double displacement, you'll have compounds, right? You have compounds coming in and swapping places, okay? So that's double displacement. So again, if you're trying to just look at you're only going to be able to see the left side, right? Like this side here. So you want to be able to kind of go, oh yeah, see there's two elements there, okay? There's one thing here. We have one metal coming in, okay, and then there's a compound. So there's an element, then a compound, right? Here there's a compound and compound, okay? So they're all looking different here. So be able to, differentiate between them. And then the last one here, yes, it is a compound and compound, or compound element, but it's be able to recognize that you have oxygen and a hydrocarbon. Oh yes, this is the one that you're burning, combustion, right? So then from there you can just pick carbon dioxide and water. Okay, so So yeah, so looking at this one here, what do we have for the reactant? Okay, we just have this one item here. So if you're looking here, what do we have that's one item? Okay, and you can see, oh yeah, that's the decomposition. So you want to write that in. Again, we're just going to find the reaction types and then we'll predict the products after. Okay, here's the next one. So we have magnesium and we have oxygen, diatomic compound or elemental compound. All right, so we have an element and element. Okay, so an element and element. What does that look like? Okay, so you're looking up here and you're like, okay, single displacement has a compound, double displacement has a compound, combustion has a compound, okay? So then you're like, well, it's not decomposition. It's not one thing breaking apart. It's a couple things. So it's a synthesis reaction, okay? And then so as you're going through, like you can go to the next view, see, same thing here, here, yeah, another element and oxygen, right? So these are all synthesis reactions, okay? Okay, so that brings us to the next ones here. So we have carbon dioxide and water. Okay, so right away maybe you thought, oh, is that like the combustion reaction, right? So if you take a look up here, the combustion reaction has those as the products, so it's not combustion, okay? All right, so then you're trying to figure, okay, what's going on here? We have a compound and it looks like another compound, and so you're looking around and trying to figure out, what does it look like here? So maybe is it a double displacement and so forth, okay? So now when we're looking at compounds, I want you to look more specifically. When you have a compound, we're looking at an ionic compound, so something that's a metal and non-metal, okay, coming together. So yeah, in this case here, we don't have that with water and we don't have that with carbon dioxide, okay? So what you can do here is you can kind of look around and go, okay, where have we seen that? So we have a carbon dioxide and water, okay? So you're kind of just like, okay, it's not the decomposition, but let's look at the synthesis here. So we did have a non-metal oxide, like carbon dioxide, and water. Oh yes, so it's the synthesis reaction. So if you have a carbon dioxide and water, you're going to get an acid, okay? So this is a synthesis reaction, okay? All right, so, and then let's look at this one. This is an iron oxide or iron 3 oxide with water. So same thing, a metal oxide with water, okay? So there it is as well, and that's gonna form a metal hydroxide, okay? But another example of synthesis reaction. Okay, so we'll keep going on here. So we have now, so again, just ask yourself, you have a couple of reactants, okay, so not decomposition, but what kind of reactants do you have? You have a metal, and then you have this metal oxide, so you have like an ionic compound here. Okay, so like again, I know you had an ionic compound here, but you didn't have another one, so that's why we went and looked at the synthesis box. Here we have a metal and ionic compound. So where do we see one metal coming in with an ionic compound? That's a single displacement reaction. Okay, so now that you seen that, the next step will be when you predict the products is will aluminum be able to take out the iron? Okay, but we'll do that in a bit. All right, here's the next one. So I'll put it in single displacement in a second. Here's the next one. We have lead nitrate and potassium chloride. Okay, both of those are ionic compounds. So we're taking a look up here. Oh yes, compound. So this is a double displacement reaction. Okay, all right, and then we have the next one. It's a hydrocarbon and oxygen. So what kind of reaction is that? Oops, I wasn't supposed to show the products. That's going to be a combustion reaction. Okay, so the next step that we need to do here is to predict the products. So I think so now that we figured out the reaction type, we know kind of where to look in the rules in order to figure out what kind of products we'll have, okay? All right, so, and again, we have to get our nomenclature correct, right? We got to get the correct chemical formulas and so forth. All right, so decomposition is the first one. So we're taking a look here as a review. So we know it's one thing breaks into a bunch of pieces. So let's look in the decomposition box here. So we have all these different types of decomposition, right? So we have a KClO3, so potassium chlorate. So if we take a look here, we're going to see that potassium chlorate breaks into potassium a metal chloride, and an oxygen. Okay, so again, so we need a metal chloride, so potassium's a charge 1, chlorine's a negative 1 charge, so that's why the formula is just like this, 1-to-1 ratio. And then oxygen pops out. Remember, oxygen needs to be diatomic. I'm also giving myself enough space so that I can balance, okay, and write state symbols. All right, here's the next one. So we have synthesis reactions. We have metal and oxygen here. So basically, we have an element and an element. So remember here with the synthesis reaction, it's a binary, right, compound. Sorry, right here. So it becomes a binary compound, right? So we're just sticking them together. So if we're putting magnesium and oxygen together, magnesium has a 2+ charge and oxygen has a 2- charge. So it'll be a 1-to-1 ratio in this formula here, like that, because the 2's will cancel out, right? Or if you charge balance, the charges balance. Okay, next one, we have iron, okay, and oxygen here. So same thing, synthesis reaction, which is going to combine together. So we're going to pay attention. All right, what charge does iron have? We have on our periodic table, we have a 2 and a 3, okay? And on our periodic table, it's kind of hard to see, but there is one that's bolded, and that's supposed to be the more stable one, okay? But in the end, so if you just wanted to write one, just write the one that's more stable, so the one that's bolded on the periodic table. So in that case, it's iron 3, okay, like that. But then when you put it in with oxygen, you're just going to have a synthesis reaction here. That's what it'll look like, okay? Otherwise, I will also accept the other one, iron 2, okay, which will be, 2+ charge, -2 charge like that. And then, right, they'll crisscross cancel out, charge balance, and you'll get that, okay? All right, so whichever one you do, and then you try to balance it, that's what, yeah, just kind of look at which product you have. All right, next one, synthesis reaction. We have our carbon with oxygen, so we have an element with an element. So these are going to just combine together, just like that. Okay, so when it's the ionic compounds, so metal and non-metal, so just kind of pay attention to the charge that they'll have, and then build them together. When it's non-metal, just stick them together. Okay. All right, here's the next one. We have carbon dioxide and water. So we have a non-metal oxide and water. So same thing, these will just combine right together. So we have 2 hydrogens, we have 1 carbon, and then the oxygens are written at the end. So there's 1, 2, 3 here. So 3 oxygens. Like that, okay? All right, next one. We have another synthesis reaction. So we have a metal oxide and water, okay? So in this case here, if you take a look, right, so we get a metal oxide and water forms a base, non-metal oxide and water makes an acid. So this one, we're going to create a metal hydroxide. So the metal here is iron 3. So you're going to have iron 3, hydroxide, like that, okay? So, yeah, because we have iron 3. All right, so we got a metal hydroxide. All right, single displacement. Let's take a look here. Aluminum comes in and tries to take out iron. So we're looking at our chart here. So we have aluminum and iron here, okay? So aluminum is higher, so it's more reactive. So yes, it will be able to displace the iron. So what's going to happen here is the iron will be by itself, right? But then the aluminum will pick up what the iron had, which was the oxygen. So again, it's an ionic compound. Just use your charges here, okay, to figure out what the formula will look like. So then you'll get to here, aluminum, 2 of those and 3 of those, okay. All right, double displacement reaction. So these just swap places. So again, pay attention. We have lead 2. So lead 2 will now be with chlorine. And then potassium will be with nitrate. Okay, all right, double displacement. All right, and complete combustion reaction, so we always just get the carbon dioxide and water. Okay, and I know some of you will ask, can I write the water first and write carbon dioxide later? Yes, that's fine. Okay. All right, but yes, those are the main, those are the products for a complete combustion. Okay, so now you got the reaction type, you found the products, and you wrote the correct formula. So now it's just, balancing them and then writing the state symbols. Okay, so if you feel comfortable with step 3 and 4, you can stop the video and just start working on the practice. Okay, otherwise, let's continue here and we're going to balance. Okay, so I'll balance the first few with you, and then from there, um, I'll just put up the answers and you can kind of take a look and see how it's going. I'm just going to use the numerical way where I multiply up the elements to make them balance. But if you prefer to use the picture way or doing guess and check, go ahead and do that and double check your work, okay? All right, so for the numerical way, I'm just going to list off all of the different elements that we do have. So here in this first compound, we have a potassium, a chlorine, or here I'll keep the I'll break up the chlorate into these. Okay, so I have these 3 elements. The first one's potassium, next one's chlorine, and then there's 3 oxygens. Okay, all right, and then this is kind of the midline to go to the products. So then we have 1 potassium, 1 chlorine, okay, and then we have the 2 oxygens like that. Oops, so put 1 and 1, okay. All right, so from there, I'm just going to use a different color here. I'm going to start balancing. So we have potassium, yeah, looks good. Chlorine looks good, okay, but the oxygens don't look good. So we have a 2 and a 3. So let's multiply those up. So when they're odd and even number, multiply them up to a common number, like 6, okay? So we'll multiply this by 2. Multiply this by 2, multiply this by 2, okay? So from there, changing the oxygen, because like chlorine and potassium were balanced, but we had to adjust the oxygen here. So in that case there, we went up to 6, and then that ended up changing potassium and chlorine as well. So let's adjust those as well. So we multiplied by 2, so we did that here, did that here. Okay, so now chlorine, there's potassium, there's 2, chlorine, there's 2, and oxygen, there's 6. Okay, so now they're balanced, so you can put the coefficients in front. Don't forget to do this part. Okay, and then we go to there. Okay, we'll try another one here. Maybe we'll go with the H here. Okay, so we have a double displacement reaction. And polyatomics involved as well. So here we go. So we have lead, and I'm noticing that the nitrate polyatomic ion is in the reactant and it's also in the product. So I'm going to keep NO3 together. Okay, so how many leads? 1, nitrates 2. Okay, and then we have potassium chloride. There we go, 1, 1. And then we have lead 2 chloride. Okay, we got 1 lead, 2 chlorines. And then we have potassium and nitrate. Okay, 1 and 1. Okay, so there's no bracket here, right? So no subscript came down, so there's only 1 polyatomic NO3 nitrate ion. Okay, so from here, let's balance these out, okay? So we're looking at lead. Lead looks good. Nitrate, nope. We need 2 of these, so we'll multiply here, 2 and 2. Okay, so now potassium needs 2, so we'll multiply this by 2, multiply this by 2. Okay, and then lead looks good, nitrate looks good, potassium looks good, and chlorine looks good. Okay, all balanced. So let's write our coefficients in, 2 and 2, like that. Okay, so we're all set. It's all balanced. So the key thing here was to put the polyatomic kind of as one clump of, kind of carry that in your head. How many of those do you have? Okay, it's much easier than going, okay, there's 1 nitrogen and 3 oxygens that I have to balance. All right, the next one is a complete combustion. Remember, for this one here, the strategy was to, with the other ones, it doesn't really matter which one you do first and so forth. So, but with these ones here, you should do them in this order. So you should, balance the carbon, balance the hydrogen, and then balance the oxygens like that, okay? All right, go in that order. And then that way, if you don't want to memorize lots of different ways to balance, just kind of, whenever you have carbon, hydrogen, oxygen, go in this order, okay? Leave oxygen till later. All right, so we're going to do that here. Sorry, I'll go to a different color here. All right, so we have 1 carbon, 4 hydrogens, okay, and then we have 2 oxygens, and then we have 1 carbon, whoops, 2 oxygens, 2 hydrogens, 1 oxygen. Okay, all right, so let's balance these. Okay, so so again, use our strategy. Carbon first. Carbon looks good. Hydrogen next. Hydrogen, there's 4 on the left, so we need 4 on the right. So I'll multiply this by 2, and multiply this by 2. Okay, so hydrogens are good, 4 and 4. Carbon's still okay. Look at oxygen now. So we have 2 from the carbon dioxide, 2 now with the water. So there's 4. So then that means we need 4 on this side as well. Okay, so all together, 2 of those and 2 of these to balance out this combustion reaction. Okay, so from here, I'm just going to put up the answers, and you can double check your work, and then we'll do the state symbols after. I just balanced B here. So we had 2 magnesiums, 2 oxygens, 2 magnesiums, 2 oxygens, okay, using the numerical method. And then I noticed that I put a 6 here by accident, so I fixed that. So just in case you're watching the video and going, why did you put a 6 here? You multiplied by 3. So anyway, I fixed that. All right, we'll keep going here. Okay, so went through and balanced everything here. Just one thing I wanted to note here was that if it is already balanced, once you guess and check or draw the particle pictures or do the numerical method or whatever method that you use, right? If you feel that it's already balanced, it's good for you to clarify this and just kind of jot it down, already balanced. So I checked it, it's already balanced, okay? Because I need to know that you didn't just leave it because you didn't know how to do it, or did you actually check and see if it was balanced? And oh yeah, it was balanced. So, so just make a little note saying already balanced, okay? So I've analyzed it, it's balanced, whatever, okay? So just say balanced already. So where if it isn't balanced, then I want you to write the coefficients in, okay? So we had a couple like that, already balanced, right? Because with the synthesis reactions, we're just sticking those nonmetals together, or we're sticking the nonmetal oxide with water right together. Okay, and yeah, sometimes you're going to have polyatomic ions come out on the other side, but sometimes they will be, yeah, just broken apart. So, for example, yeah, like, I don't know, kind of like that, like the chlorate was broken apart. So just be ready to count them in pieces if that's the case. Like here, here's carbonate, but you didn't see carbonate in the reactants, right? So just kind of count out all the elements if that's the case, if you're not seeing the polyatomic on the left and then coming out on the right, okay? All right, so now we are going to move into the last step here. End of our lesson now. I want you to write the state symbols. So go back and review the state symbol video if you're not confident here, okay? And then you're going to go through and label, yeah, the state symbols in the right corner here, small, like the subscripts, okay? Okay, so what I'm doing here is I'm just showing you the reaction equations with the state symbols. I'm not showing the coefficients and then all the balancing work and all that stuff, okay? All right, so just to kind of make it easier to see where the state symbols are. All right, so again, hopefully you reviewed the state symbol video and those notes. So as we're going through, if we have a decomposition, so what we'll do is we'll start with some substance, a compound, and we'll add heat to it, okay? So imagine with this first one, potassium chloride, we're adding heat to it. So what's going to happen is that it will break down. You'll see well, there will be oxygen that will be released, and then that leaves us the metal chloride, okay? So you start with the solid, deheat it, you still have the solid, but the gas will escape as well, okay? So this is how you label that. All right, synthesis, so we're going to leave stuff out in oxygen here, and so then it's going to form an iron oxide or magnesium oxide, metal oxide. So, so this solid reacting with the gas will still stay solid, okay? So you leave a car outside, and it'll eventually form some rust on it. All right, so same with iron here, iron, oxygen. Sorry, I didn't write this in. This should be, oops, solid as well. And then here, what was this one? Sorry, oops. Okay, there. Okay, so yeah, solid left over. Okay, and here we go. We have some carbon. Okay, so think like that's they call it the lead in your pencil, but the solid that's in your pencil that you write with. So carbon is a solid. So what we're going to do in this case here is we have oxygen with it, okay? So we're going to, combust this. It's like an elemental combustion, right? So, and then what will happen here is that we'll get the non-metal oxide forming. Okay, so that's gaseous. All right, so if you get the non-metal oxides are always gaseous. All right, and then from there, synthesis reaction here of carbon dioxide with water. So we're sending carbon dioxide into the air, it's mixing with the water in the air and falling in as acid rain. So acid, it's mixed, so the carbon mixed with the acid there will be an aqueous solution. And we've seen that, right? All acids will be aqueous for our year. Okay, and then magnesium 3, iron 3 oxide. So same thing, we have our ionic compound, we're mixing it with the water, okay, and then we're going to have a base that forms. So base is aqueous. All right, and then we have our aluminum coming in to displace our aluminum. And then, so this is like our lab. We put the aluminum into a solution, and then we get a single displacement reaction where it's still aqueous, and then a new metal forms here, right? The iron forms. All right, and then, so double displacement, you start with aqueous for the reactants, but then analyze the products, remember in the table here, in order to figure out if it's a solid or not. So we have lead 2 chloride. So if we look here, no lead, no chlorine in the first box. Go to the next one. Chlorine with lead 2 will form a precipitate. Okay, and potassium nitrate. So remember anything group 1 and nitrate, those are always aqueous. All right, and last combustion reactions, right? We're burning, so everything's gaseous. Okay, so I'd say probably the toughest thing here is probably maybe coming up with the products. Okay, I think balancing should be good now. And then, sorry, no, you know what? The hardest thing I think it might be the state symbols. So keep working on those, and and then be able to produce all the products balanced and ready to go. Okay, so this is the day. Practice lots. Okay, in order to get confident with these.